In this problem, we will look at another chemical stoichiometry problem and introduce the idea of percent yield. So the reaction we're going to look at is the result of a piece of sodium being dropped into a beaker of water. As with all chemical stoichiometry problems, you're the one who comes up with the recipe. And the recipe in chemistry is the balanced chemical equation. So that's what we need to do in this first part. So sodium plus water, it looks like it might be a single replacement reaction. So I look at my activity series, I see sodium is more reactive than hydrogen. So sodium will replace hydrogen. Now remember, water is really hydrogen ions and hydroxide ions together. So sodium replaces the hydrogen and hooks up with hydroxide. Hydrogen is released, and you have to remember that hydrogen by itself is going to be diatomic, and of course it's a gas. That gives me the skeleton equation. I balance it, and when I balance it, I now have my recipe. The ratio is 2 to 2 to 2 to 1. These are molar ratios. I'll utilize them whenever I do my stoichiometric calculation. So in B, we are given 6.8 grams of sodium, and we are to figure out how many liters of hydrogen gas will be produced at STP. So I start off with the sodium, and I know that the ratio between sodium and hydrogen gas is 2 to 1 or 1 to 2, but that's a molar ratio. So you can see in this first step I had to first of all get sodium into moles by dividing by its molar mass. Now I can use the molar ratio from my recipe between sodium and hydrogen, and I get only 1 hydrogen for every 2 moles of sodium that react. And then we are asked to figure out how many liters were being produced. I'm assuming this is an STP, and therefore I can use my molar volume, 22.4 liters. My labels again cancel out. I do my calculation, and I predict, this is just the theoretical yield, I predict we're going to get 3.3 liters of hydrogen. So remember, theoretical yield is the predicted amount. That's not what we would necessarily get when we run the experiment. In part C, we have run the experiment. And when the experiment was run, this particular group was able to capture 965 milliliters of hydrogen gas. So we're asked to find the percent yield. Remember, the percent yield is a comparison between the actual yield and the theoretical yield. So actual yield is always a measured amount, one that is achieved experimentally. Theoretical yield is always a predicted amount, it's always calculated. Now be careful, the units for these two volumes have to be the same. Either they're both in milliliters or both in liters. I chose to change milliliters to liters by moving the decimal over 3 places, and obviously my theoretical yield was already in liters, and in this case we ended up with a 29% yield.